Okay, this is just kind of a brief introduction to SPSS, its format, and some of the basics of descriptive statistics and graphs. And then as we go through the class, I'll give you more instructions on more details as you need them. But in your Brightspace, you'll find learning styles. It's an Excel data set. You'll want to download that and then save it to some drive where you know where it's at. Maybe it's the desktop, maybe it's your H drive or your USB port, wherever it is, make sure that you download it and then save it there. I also have 3 other documents related to SPSS. One is the instructions, and this is where I give you the point to this, click on this, type this in SPSS. And then here's an exercise report where as we go through today, I'm going to ask you, we're going to produce some output and things like that. If you were to create an assignment for something like this, I'm just going to show you how to copy and paste stuff over in there and then interpret it. And I give you some example exercises, example answers also in this other document. If you open up the Learning Styles Excel sheet, here is the data that was acquired from your participation in the Qualtrics survey. So that was kind of fun. I asked you what your learning style, what you thought it was. I asked you what class you were in, your gender, age, your preference of online versus on-campus classes, what field of study you were in. I made this new variable called style score, where I have an indicator of which of these was your highest score. And then it's your actual scores, and then your level of interest and anxiety towards this class, and your code name. So if you don't remember any of those, then in the introduction and exercise instructions, I give you a list of what those variable names are, what question they corresponded to in the survey, and then the values, because you'll notice you don't see gender, male, female, male, female. You see a bunch of 1s and 2s. So the coding for that is that 1 equals male and 2 equals female. And that's how all data are stored, not with texts of descriptions, but rather with indicator numbers. Let's load this into SPSS. If you click on Start and you find the SPSS, some computers have 21, some have 23. It doesn't really matter. There's only slight changes in those. It's going to ask you what data source you want to open up, and I just click cancel here. And then I go to File, Open, and Data. And the file that we're looking for is not an SAV file. Specifically, it's an Excel file, so you'll have to change that at the type, and then locate where you have stored your learning styles data. So mine is on an external hard drive. And then click Open. I just want the first worksheet because that's the only one that I have. And here we're telling it that yes, the variable names are in the first row. And click OK. So here is the data set. Raise your hand when you're able to open it into SPSS. Mm-hmm. Open. And OK. Raise your hand when you get it open. Okay. I'll still wait. Okay, good. Good.
So I saved it to my hard drive. So can I go and click on it?
go up some levels. So up some more levels. And change this to Excel. There it is. So open, Excel, change that. There it is. And then where did you save it? Okay, so scroll all the way up and then desktop. Okay. Good, good. Here. Okay, change this to Excel. And then where'd you save it?
This one.
Okay, so put this down and scroll all the way up. And go to desktop. Open and then okay. Good. This is the data viewer or the data editor in SPSS. And you'll notice two tabs at the bottom. This is the data view tab where you see the actual data. The other one is the variable view. So I'm going to put it beside my instructions so I can see. The name of the variable is very specific. This name can't have spaces. The name of a variable can't start with a number. So here, that's where I put style, class, gender. Whenever you start a project, I would recommend really cleaning up your data and putting in some details so that you don't forget later. For instance, what does style stand for? Well, it corresponded to this question. What do you think your learning style is? That's what you can put, I'll copy and paste it into the label. SPSS is pretty good about copy paste. So actually what you can do is I formatted it specifically so you can copy that column of information and you can paste all of those as labels on your data set. Let me know if you're able to label all of your variables by raising your hand. Okay. The next column that you see is values. So style, we see 1, 2, and 3 in our data set, but what is the value of each of those numbers? I can use the values here, so I've given you the indicators, and tell SPSS that 1 is labeled as visual, add. 2 is labeled as auditory, add. 3 is labeled as kinesthetic, add, and click OK. You'll notice that it changes your value there. Values should be input for all of your categorical variables. So now I want you to change all of the values, and there's no copy paste here, sorry. But change all of those that I've given you values to over here in your actual data set. Okay, I kind of skipped over the type of the variable. Most often we just have numeric variables, but notice that SPSS recognized that code name wasn't just numbers. It was also letters, and so it calls it a string. So it's not going to allow us to make descriptive statistics of code name. We don't take the average code name because it's a string. It's not numeric. If we had measures, then we might want to allow 2 or 3 decimals in the view. So we could change that here by adding or taking away decimals. If we have missing variables in our data, which we do, you'll see here the 33rd person didn't input their age. That's okay. SPSS recognizes that as a period or a dot. Sometimes if you download data or you store data, some people will store missing data as 999. If you do that, then in the missing, you should go in and put missing data as 999. Otherwise, when you go to calculate descriptive statistics, it's going to think somebody in the class is 999 years old. So specifying that what missing values are will be helpful to you whenever you analyze that. But by default, it does the dot and you don't have to put any specifications. The last column is measure. This is also an important one because certain analyses can only be done with certain types of variables. So our options are nominal, ordinal, or scale. Scale is a ratio or interval. It's a number we add, subtract, divide, so on and so forth. Style, it thinks that style is a nominal variable. Would you agree with that? Yeah, I would too. Are there any of them that you think SPSS didn't read correctly that should be changed? Should any of those be changed? What do you think?
Should the radio level of interest in level anxiety scale?
Okay.
I mean, not scale, ordinal, rather.
Maybe ordinal.
They should theoretically equally distant from one another.
Right. So interest, are you extremely interested? Are you not interested at all? That's an ordinal measure. Likewise for anxiety, average, below average, above average, that's an ordinal one also. The other ones, though, I think are okay. Now, if you go back to your data view, you see it as you saw it before, but since we have values, click on this little toggle up in the top. It has 1A, labels, values. Click on that, and what do you see happen?
The numbers get their label.
The numbers get their label or their value, yeah. So that's another reason that inputting that information might be helpful to you. Next, I want us to create a new variable. So right now, age is continuous. You could just input your age in years, but I want to classify age, and I want to group people into categories by age. Specifically, I want to group them into groups of 20 to 29, 30 to 39, so on and so forth. To do that, click on Transform, Recode into Different Variable, find the age variable, and put it into the middle box. You can click it and drag it, or you can click it and use the arrow. Then I want the output name, so I want the new variable name to be age classify. Change. You'll see it changed what the variable name is going to be. Then click old and new values. I'm going to use range, and I'm going to tell it if the range is from 20 to 29, let the value be 1. If the range is 30 to 39, let the value be 2. 40 to 49, the value be 3. And the range 50 to 59 be 4. There are other options that you could choose there depending on how you were creating that new variable. Click Continue and OK. So it popped up this new window that's your output. Anytime we do analysis, the output is going to come here. Right now, it's just keeping a log of what we've done. So we have opened a data file. Mine was in the E drive. And we've now recoded this variable age into a new variable called age classify. Here in my data, if I make it a little bigger, I see at the very end my age classify. So is age classify a nominal, ordinal, or scale variable? Ordinal, very good. And we should go in and put the values and labels for that new ordinal variable. So 1 was 20 to 29, 2 was 30 to 39, 3 was 40 to 49, and 4 was 50 to 59. Raise your hand if you're with me. Okay, I'll wait. Let me know when you're done, or if you have questions.
I actually keep outside at this one, but
Let's change.
Oh, that's.
No.
No, she said she
Okay, now let's get some descriptive statistics. At the top, click Analyze, and then Descriptives. And let's go to Frequencies. So I want to know how many male and how many female are in my sample. I take the gender variable and put it in the middle. And then there's various things we could do. We could actually get additional statistics of the mean and the standard deviation here, if you want. But since they're not, since it's a categorical variable, is that appropriate to take the average gender? No, so we won't do that. We could get some charts. We can also change the formatting by ordering in terms of the value, male, female, or by the frequency. So if I put this in descending count, it's going to put the highest frequency category first and then descend. When you're done, click OK. It brought this up in the output window. Did you all get some output? For yours, is the title of your table, what is your gender? And are the labels male and female? Did anybody's label these just 1 and 2 by the actual numbers? No, so we're good. Sometimes it does. So I'll just walk you through this in case it does in the future. If you click Edit and then Options, and then Output. This changes your output. So the outline labeling is this outline of the output here on the left-hand side. And notice it labeled what is your gender. But instead, I want it to have the name of the variable. So I'm going to change this to name. And the pivot table labeling changes what labels are produced in your table. So if I change the value to the value, it's going to print 1 and 2 instead of male and female. So I'll show you this. You don't have to do it. But now if I analyze and I go to frequencies and I produce that same table, notice here, instead of producing the label of the variable, it produced the name of the variable. And instead of producing the value of the variable, here it has 1 and 2. That's not helpful for me, so I'm going to change it back. But I do like just the name here on the left. Let's see, labels, names. Okay. What if we want a contingency table? What is it? Do y'all know what a contingency table is? Or a crosstab table? A crosstab table looks at the relationship between two categorical variables. So maybe you want to know within the male and female genders, how many people were in each class? So from 5953, how many male and female? And from 6003, how many male and female? So we go to Analyze, Descriptive Statistics, and now Crosstabs. Let's put, and it doesn't matter if you do row or column. Let's do gender for row and then class for column. And click OK. So this says that in 5953, how many males were there? And how many female? How many? 11, yeah. And how many females are in 6003? 13, good. A lot of times we want to know, well, what percent is within each of those categories? Go back to that cross tab. And in in cells, click percentage. We can do percent within rows, within columns, or within totals. I'm just going to click all three for example purposes, but typically you wouldn't do that. Click continue and OK. So now we see the percentages of my different groupings. So here I have male, the percent of male within gender. So do you think that this 53% is the 7 out of 18 or the 7 out of 13? 7 out of 13. So percent within gender is 7 out of 13. So there are 53% that are in 5953 of the total number of males. What is this interpretation of 61.1? It's 11 over what? Not 7. 11 over, it says percent within which variable? Class. And what is the total number of classmates in that one? 18. So it's 11 over 18. So within this class of 5953, 61% are female. Let's do one more. What is 46.2? 6 over 13, very good. So within all males, within this whole grouping here, 46% are in 6003. So that's the difference in your row percentages and your column percentages. Now let's do some descriptive statistics. Analyze descriptive statistics and go to descriptives. Maybe we want descriptive statistics of age. So we can put age in the variable. SPSS is smart. You can put a lot of variables in at once. So maybe we want to know also the scores, the descriptive statistics of my 3 different scores. So I'll put that over there also. And click OK. So now the syntax here, this is just what did SPSS do? It said create descriptive statistics for these 4 variables. And by default, it calculated the mean, standard deviation, minimum, and maximum. And that's what we see here in our table. So what's the average age of the students in my classes? 33. Which score was the highest? Most students are what score? Visual, yeah. Well, that didn't necessarily answer that question, but across visual scores for all students, it was the highest among auditory and kinesthetic. Yeah. But what if we want to know those scores within gender? Yeah. So we go to Analyze. Now compare means and means. And let's put those same 4 scale variables in the dependent list. And let's put gender in the independent list. That could be layer 1. Maybe we also want to know those groups within another factor. Which one do you want to look at? You want to compare scores for students in what? Different learning styles, okay? So let's pick the top scoring learning style and put that in the independent list. And then click OK. Oh, darn. That's not exactly what I wanted to do. It did level within level. I don't want to do that. That's too much. So go back and take off your level 2. Sorry. Yeah. So just have a level 1. And I'll get this report here. That looks a lot better. Raise your hand when you get that table out. Yeah. Okay. Good. So within males, what's the highest type of score? Visual. Within female, what is it? Visual, yeah. Okay, so we can look at averages within certain groups. Any questions about those descriptive statistics? Okay, let's make some graphs then. So we'll click on Graph and Chart Builder. Let's do a bar chart first. What variable do you want to make a bar chart of? You pick. What variable do we want to make a bar chart of? Scores. What's the difference in a bar chart and a histogram?
Histograms for continuous data?
Yes, histograms for continuous data. Bar chart is for
Discrete.
not just discrete, but categorical data. So I want a categorical variable for my bar chart. Which one do we want?
Is it online or in class?
Online or in-class preference. Okay, so take that first bar picture, put it in the middle, and then put preference on the x-axis and click OK. So there we have a bar chart of online and in class. Let's go one step further. What if we want to know, do you prefer online or in class within another subcategory?
Maybe your discipline, your academic discipline.
Discipline, okay? So go back up to your graph and chart builder. And instead of the first bar chart, click the second one. And now at the top right, you see cluster on X. Put your secondary variable up there. So here is relates to your field. And click OK. So what does that tell you about the business students? None of the business students like online. What about the health students? About equal, yeah. And what about education? They tended to prefer in class, and likewise for psychology. Good. Now let's make a histogram. So we need a continuous variable for a histogram. Go back to your chart builder and click on histogram. Click and drag that first one into the main box. And what variable do you want to do?
Age, and then we could do different scores.
We could do a different score. We could start with age. Yeah. So what is your age? We'll put that in the middle and click OK. There we go. What are some observations about that histogram that you get?
It's skewed.
It's skewed, yeah.
I think it's-
Go ahead.
I think it's interesting how it jumps up to, our average and then drops down before 50 and then increases again.
Yeah. It's not just a continual decrease in age, kind of like what we would expect. There's a decrease, but then there's actually another increase towards the end. Yeah. In addition to interpreting the age distribution for this class, just evaluate that histogram critically. So what do you observe about the histogram itself? Ignore the factor of age. What do you notice?
It gives some descriptives.
It does. It gives us some descriptive statistics, the mean, the standard deviation, the sample size. That's helpful for a graph. Anything you'd like to change about the structure of that histogram?
I'd like to be a bit more specific in meters.
Okay. How much more specific?
Maybe going by fives or twos.
Maybe going by fives or by twos. One big problem that I see with it is the bars don't align with the axis. Do y'all notice that on yours? Furthermore, I don't like the default brown and gray. So let's change our histogram. If you double click anywhere on the graph, it brings up the chart editor. Now, this is where we can change different properties. So maybe it's okay that our axis goes from 10 to 20 to 30 to 40, 50, 60. But I want to change the bars and the structure of the bars. So double click on the bar. And you'll see the tab called binning. This is where you get to choose either the number of total intervals that you want or the interval width. So if I change the interval width, let's start with 5. And click apply. And see how it changed. You could just test it out. Try, what is an interval width of 2? Which one do you like better, the 5 or the 2? Some like the 2, some like the 5. You get to choose whichever one you like. I'll go back to the 5. This is also, notice you have fill and border. So your fill color, maybe you want to make it orange. Maybe you want to get crazy and make it stripes. There's all kinds of things within reason. I don't really recommend these, but it's kind of fun to play around with it. Changing the style of what your graphs look like. You can make the borders thicker. And you can also change the chart size. So it might not look any different on your screen, but when you go to copy and paste a chart, it holds its format. So you can't change the size of the text or anything like that once you move it into Word. But if you close that, maybe now we see, oh, it would actually be helpful if the axis went by 5s instead of 10s. So if you double click now on the x-axis, then you get a tab called Scale. This is where you can specify the minimum and the maximum and the increment. So if I change the increment to 5, now it will label 20, 25, 30, 35. Here you can change the text style. So we typically like Times New Roman. And maybe we want it a little bit bigger and apply. If for some reason we wanted that age to have a decimal, then we could add a decimal in the number formatting. We don't really need to though, because it's pretty clean as it is. So I'll click close. Notice on the output window back here, nothing changed, but once you exit out of the editor, it changes on your output. So this is a good time to go up and save this output. So File, Save. Notice that the type is an SPV. This is an output file of SPSS. So I'm just going to save it here. Learning styles. Output, I'll call it 2. And save. So that's good and not so good for a few reasons. The reason that I recommend saving your output is because maybe tomorrow you come back in and you want to pick up where you left off. You don't want to have to make that chart all over again and change the formatting, because every time you start afresh, it produces that ugly brown and gray. So now you don't have to redo that. The reason that you might get frustrated or forget something is because that SPV file only opens in SPSS. You can't open this whole output in Word and then copy and paste things. So only on a computer that has SPSS can you access this output data. So just want to make you aware of that. The same thing with the data file. If you go in and now save this SPSS data file, it only will save and open in SPSS. You can't, once it's saved in SPSS, you can't upload it into Excel. That's kind of the basics of charts and graphs. Any other questions related to that? Okay, now I'm going to go through just an independent t-test, a dependent t-test, and the basics of ANOVA, okay? Okay, so you tell me, you can kind of guide this. What is a question we could evaluate using an independent t-test with this data?
Is anxiety significantly different between males and females?
Okay, is anxiety significantly different between males and females? So we go to Analyze, Compare Means, and Independent Samples t-test. The dependent variable is the test variable. So we'll put anxiety there. And for male and female, that's my grouping variable of gender. It's going to want you to define your groups. So our indicators were 1 equal male, 2 equal female. So I'll just put 1 and 2 in groups 1 and 2. And click Continue. And then click OK. Did you all get your output? Okay. So I went over the assumptions of ANOVA, or of the independent t-test, because of this. I knew we were going to do this. By default, you get Levine's test for equality of variance. And what did we say? We wanted a big or a small p-value for Levine's test. Big. The significance is the p-value, and I see 0.23. So am I rejecting or retaining the null? Retaining. So am I going to say that equal variances are assumed or not assumed? They are assumed, yes. So we are meeting our assumption. So I'm going to look at this row of output. This is the t statistic, negative 0.399. The degrees of freedom are 35. And the two-tailed p-value or significance is 0.69. So is the anxiety significantly different for males and females? No, it's not. That's probably good, though. We can see here in our group statistics that the average was slightly a higher score for females than it was for males. Good. What's a question we could analyze using a dependent t-test? What is a dependent t-test? Not sure? Okay.
I'm sorry, can you say the question again?
When do we use a dependent t-test?
Before and after type of tests. When one score is dependent upon the other score.
Okay, when scores across two sets of data that we're comparing are dependent on each other. When we're comparing males and females on some variable, they're independent. Scores from the females should not affect scores from the males. But if we're doing something like a pre-post test, where you have an observation in the pre-data and in the post data. So observations in those two sets of data are dependent on each other.
I have a question. Would you, like, I guess you run a correlation or something to ensure that the two data sets aren't related to one another? Like, let's say we're running this, but we're looking at only married couples taking ANOVA together. Theoretically speaking, they should affect one another, because if they're married couples, the couples go home, and then they affect one another because they live together, they be left together, yada yada.
Very
so,
true.
like, when you run a correlation to ensure that they're not related, or is it just assumed because they're not the same person?
Well, then I would ask, why not do a dependent t-test for that group?
Because you're still looking at the level of anxiety for men versus women.
Yes.
But all the men happen to be married to all the women. Like, couples, not like big group marriage. Then, but you don't know if you should do one or the other, because you don't want to assume that they impact one another. They all could have bad marriages. Or you don't want to assume that they aren't related, because they all could have really good marriages and they could impact one another. So how do you determine whether or not they're related? Is it correlation, or is that something else that you were talking about?
There's not an indicator of independence in terms of like a test or something like that. You could use correlation to see what the overall relationship is. But the independent t-test and the dependent t-test both look at, are there significant differences in the averages of these two sets of data? So if you suspect that the two sets of data have some dependency, I would go ahead and run the dependent t-test. And sometimes they will actually, like, specifically do a dependent t-test when you have males and females and you have couples that are married, or you have two different exercise regimes and you give them two sets of twins, because there's so much biologically that's the same among twins. Dependent t-test. So it doesn't just have to be like a pre-post or the same observation on the same person. It can be two sets when you think that those two groups are dependent.
And when you break it up, you just cite other articles where, we used twins, so we did it. So you'll say, well, Cole and friends did it this way.
Right.
So therefore I'm doing it this way too.
Right. Yeah. When we talk about power of a study, a dependent t-test is likely to be more powerful than an independent t-test, because it takes advantage of that dependency among your data if it's there. Yeah. So what is a dependent t-test that we could do with the data and variables that we have?
Could anxiety and interest be related to one another? We could look at the meanings between those.
Are the levels of anxiety and interest levels? You could, but we would have to do some manipulation of our data, because those two variables aren't on the same scale.
Oh, yeah, that's right.
One is on a 5-point scale and positively worded, and one is on a 3-point scale and negatively worded. So it wouldn't be a best practice to treat the data as it is.
Could you do the style they prefer in this top score that they got?
Almost, but if you look at the values of those, if I would have stuck to style being 1, 2, or 3 and style based on your score being 1, 2, 3, then maybe. But style score, they could have 2, and that wasn't an option in the initials. What do you think you are?
In that case, could you do style and anxiety?
Style and anxiety, maybe, but think about, again, the dependent t-test. The dependent t-test is evaluating significant difference in the mean. We can take means or averages of what kinds of variables? Continuous. Is style a continuous variable? Not really. So we probably shouldn't treat style as dependent variable. You're getting closer.
And doesn't that leave us with age and then specific scores for visual auditory and stuff?
Yeah. So really the only variables we can work with are the scores and age. Specifically, we want two variables that are on the same scale. So now what do you think? Two scores. Yes. So which two scores? We want to see if people enrolled in these classes have significantly different blank and blank learning style scores. Which two? Visual and auditory. Okay. Thanks for bearing with me through that conversation. I wanted you to process through and really understand tests and variables and all of that fun stuff. So we go to analyze, compare means, and now a paired samples t-test. We'll put the visual score on variable 1 and the auditory score on variable 2. And click OK. It automatically will give us descriptive statistics of the visual and auditory scores. And yes, we see that visual scores are higher on average than auditory, but are they higher on average for each student? What is the correlation between your visual and your auditory score? 0.148. Is that a high correlation? No, those scores are not highly correlated. But then if we go to the paired differences, we see the t-test statistic, the degrees of freedom, and the p-value or significance. Do we have significantly different visual and auditory scores? Yeah, we see a low p-value, so we reject the null. If we wanted to make the one-tail conclusion, we would say that visual scores are significantly higher or lower than auditory scores. They're typically higher than auditory scores. In our sample, we are more visual learners than we are auditory learners. Good. Let's do one more, and let's do a one-way ANOVA. So what kind of question can we ask and use ANOVA to analyze it? What do we think?
Could you look at all three scores? Or,
Say that one more time.
I mean, can you look at all three of the scores in comparison to age or something?
Maybe. Let's talk through that. If we want to know, are scores different for people in different ages? Are we going to use our initial age variable, or are we going to use our age classify variable? Classify. How many of y'all are going to take multivariate analysis? Okay. Multivariate is the class where you have multiple dependent variables. For us, we just have to pick one of those or do the one-way ANOVA 3 times. But for the multivariate class, you could do all three simultaneously. Which one do you want to look at? Since we're just doing one in this, everything gets more complicated as you go on. We'll analyze and now compare means. And the last one is your one-way ANOVA. So we want our factor to be our age classify. And which of those scores do we want to look at? Auditory. Dependent list. And click OK. We have an ANOVA table, just like the tables that we created last week, where we have sums of squares, we have mean squares, we have F, and we have a p-value or significance. What does that significance tell you about auditory scores for people in different age groups? No significant difference. That p-value is greater than 0.05. Maybe you want to know, well, what were the values? If we go back to your ANOVA, click on the options and print the descriptive statistics. Continue and OK. So here we see the descriptive statistics. It ranged from 19 to almost 27. So scores were kind of different. They just weren't different enough. You'll notice in the min and max, there's a lot of overlap in the distribution of those scores within groups, which again, decreases our power. So maybe we're just not able to detect those differences if they really were there. So those are the 3 tests. That's SPSS and an introduction. Do you have any questions about SPSS?
How did we do the descriptives, that last step?
In the compare means one-way ANOVA, I went to options and then clicked on descriptives. You can also get a nice little plot there, a means plot in the options. Continue and OK. And so visually, because we're visual learners more than we are auditory, we can see those age groups and how our score of auditory varies across our groups. Any more questions?
Where'd you get that?
In the options of the ANOVA, analyze, compare means ANOVA, options, and then means plot. You also have that exercise report. You don't have to turn it in. It's just for your own good. But I ask you to insert the frequency table or insert the bar chart by copy and pasting. You can do that directly out of the output. If I want this ANOVA table, if I right click on it and copy it, then I can go into SPSS and I'll just put it down here at the bottom. Then I can click paste and it puts my table in there. I also have this because it pretty much goes through everything that we did, maybe with different variables. But then I also have one in your Brightspace that is an example exercise set. So you can see and just get more practice playing around in SPSS. Verify your output.
I have a question. Do we want to have an assignment where we get to format these EPA style, like with a dark bar, light bar, dash, right, whatever?
No.
It's so obnoxious and it changes every 5 seconds, but no?
No.
Okay.
I'll talk about SPSS formatting of tables, but I won't actually do it in this class.
That is fine
Okay.
then.
Any other questions? Yeah.
But why do we delete the questionnaire, which is incomplete in this?
like ignore missing values.
Oh, yeah.
You'll notice that our data set had some missing values. So when we calculated descriptive statistics of age, it didn't have a sample size of 37, it had a sample size of 36. Or when we dealt with our scores, it had a 36 sample size because someone didn't include their own scores. So a lot of times, even in survey data, you'll have a questionnaire of 20 questions. If somebody doesn't complete one of those questions, a lot of times we disregard the whole set of observations for that person. And it's just kind of a practice thing. There are some, I don't know if they have one in our department, but in some stat departments, they will have a full course on how you deal with missing data. And so there's ways to impute missing data or estimate missing data. Typically, we just exclude it or set it aside. Yeah. But there is a lot of literature on how to deal with that. Anything else? Okay. That is all that I have for today. Don't forget your homework and your discussion for this week are both due. And feel free to contact me if you have any questions.
Really quick,